Good morning friends. Today we are discussing on venturimeter. So venturimeter is a device used to measure the rate of flow of a fluid flowing through a pipe. So here the rate of flow, in the sense it is the discharge. So now the fluid is flowing through a device which is having three parts: a short converging part, then a throat, and diverging part. The diameter of the pipe is not uniform throughout. The fluid is first entering into the pipe having the diameter D1. Then I have here a converging part. So here whatever energy possessed by the flowing fluid will be lost, because it is now entering into a part which is having the diameter less than the diameter at the inlet. So now D1 is the diameter at the inlet. So P1 is the pressure at section 1. V1 is the velocity of the fluid at the section 1, and A1 is the cross-sectional area at the section 1. So here we are taking the help of the manometer to measure the pressure difference at the two sections 1 and 2. Now D2, P2, V2 and A2 are the corresponding values at the section 2, 2. Now applying Bernoulli's equation at section 1 and 2. So section 1, that is one end of the manometer is connected at the inlet, the other end of the manometer is connected at the throat. So the section 1 is at the inlet of the pipe where the diameter is D1, and the other part of the manometer is connected at the throat where the diameter is very small. Now taking Bernoulli's equation at section 1 and 2. So what Bernoulli's equation says: the sum of the pressure head plus kinetic head plus datum head is equal to the sum of pressure head plus kinetic head plus datum head. So this is the sum of the three heads at section 1, and this is the sum of the three heads at section 2. Both are equal to a constant value. Since the pipe is horizontal, my datum head Z1 is equal to Z2. That is, the points what we have considered 1 and 2 are at the same level with reference to the datum line. So that is, my Z1 is equal to Z2. So Z1 and Z2 gets cancels here. So we have P1 by rho G plus V1 square by 2G is equal to P2 by rho G plus V2 square by 2G. So taking rho G common for P1 and P2 here, we have P1 minus P2 by rho G is equal to, taking 2G as common for my V2 and V1 here. Now P1 by rho G minus P2 by rho G, it is nothing but the difference in the pressure heads at the sections 1 and 2. So that is, P1 by rho G is nothing but the pressure head at section 1, and P2 by rho G is the pressure head at the section 2. So P1 by rho G is H1 and P2 by rho G is H2. So which is obtained from hydrostatic law. So the hydrostatic law says that the intensity of pressure increases as the depth of that particular point at which the pressure is to be measured increases from the free surface. So it is now P1 minus P2 by rho G is equal to H. That is the difference of H1 minus H2. So now, this P1 minus P2 by rho G is replaced by this H. So H is equal to now V2 square by 2G minus V1 square by 2G. Now applying continuity equation at section 1 and 2, we have A1 V1 is equal to A2 V2. Now we are writing V1 as A2 V2 divided by A1. Now substituting in H, so we have V2 square by 2G minus, so we are substituting V1 from the earlier equation what we got as A2 V2 by A1, so it is V1, so V1 square by 2G. Now V2 square by 2G is taken common, we have 1 minus A2 square by A1 square, so that is equal to V2 square by 2G of A2 square minus A1 square by A1 square. That is LCM is taken for these two quantities. So V2 square is equal to now 2GH of A1 square divided by A1 square minus A2 square. That is, so this we have H here. So rearranging the terms, we have V2 square here. So V2 is nothing but square root of this quantity. So here we are, if you simplify this, so it becomes A1 by square root of A1 square minus A2 square root of 2GH. We know that discharge equation Q can be written as A1 V1 or A2 V2. So A2 V2 it is now. So A2 into, we are replacing V2 with this quantity. So now this is the theoretical discharge. So that is under ideal conditions. But we have the actual discharge as CD into A1 A2 by square root of A1 square minus A2 square root of 2GH, where the CD is coefficient of Venturi meter. So actually we have CD, that is coefficient of discharge, is given by the ratio of CD is equal to Q actual by Q theoretical. So if our actual discharge is the same as our theoretical discharge, this coefficient of discharge becomes 1. But because of there is a pressure drop as the fluid is entering from the inlet where the diameter is D1 and it is entering into throat, that is of the reduced diameter, so there will be energy loss. So that because of that energy loss, we have the actual discharge which is less than our theoretical discharge. So my CD value remains less than 1. So CD is coefficient of Venturi meter. So the value of this H given by the differential U-tube manometer. So H is equal to X into SH by S0 minus 1, where X is the difference in the mercury levels in the manometer. So this conversion we are using because this X is measured in terms of mercury, but I want my pressure head in terms of water. So the conversion is this. So X into SH by S0 minus 1 when the manometer contains a liquid heavier than the liquid flowing in the pipe. The liquid flowing in the pipe is water and the liquid what is present in the manometer is mercury. So mercury is heavier than water. So it is SH by S0 minus 1. So SH is nothing but the specific gravity of the heavier liquid. So when the manometer contains a liquid lighter than the liquid flowing in the pipe, right? So then we have H is equal to X into 1 minus SH by S0. SL by S0. SL is the lighter liquid's specific gravity. X is the difference in the liquid columns in the manometer. Thank you.